Hey guys, here's another quick example. This one says Erica is a forest ranger in a 90-foot observation tower and sees a fire. The angle of depression to the fire is 7 degrees. What's the horizontal distance between the tower and the fire? Round to the nearest hundredth. Okay, so it says here that Erica is actually in a 90-foot observation tower. So here's my tower, and it's 90 feet. Whoops, you can't see that tower, huh? It's 90 feet, and she's up in here hanging out in the observation tower. She's a forest ranger. And it says she sees a fire. So there's a fire. All right. Obviously on the ground, fires aren't going to be floating in midair. All right, so she sees this fire on the ground, and it says the angle of depression to the fire is 7 degrees. So this is where you have to be careful. She's looking down at the fire. A lot of you guys are going to want to make this the angle of depression, and that is wrong, because an angle of depression, remember, is formed by an imaginary or real, in this case it's imaginary, horizontal line and the line of sight looking down. So that's actually the angle of depression. It's outside the triangle. And the angle of depression is 7 degrees, it says. Okay, and the question then says, what is the horizontal distance? So again, I'm going horizontal between the tower and the fire. Now, obviously, she's at the top of the tower. This is not horizontal. We're not looking for this. We're looking for the base of the tower to the fire. That is going to be our X. That is what we're looking for, okay? So remember earlier I said angle of depression and elevation are exactly the same. So the easiest way to do this problem is to recognize that the tower and the ground will form a right angle. Since the horizontal up here and the ground are going to be parallel, this angle is 7 degrees. It's my angle of depression. I can also say the angle of elevation is 7 degrees because they are equal. And what I'm going to do is use trig then on this triangle here, right there, okay? And in order to use trig on this triangle, what I will do is, obviously, I'm going to circle my reference angle and then label everything. I have the opposite. I'm not using the hypotenuse at all. I'm going to use the adjacent. You'll notice tangent is used a lot in these problems. Okay, opposite over adjacent is tangent. So I'm going to write out my trig. I'm going to say tangent of 7 equals 90 over x. Put this over 1, cross multiply. So x tangent, I'll write the whole thing out so you can see this one. X tangent of 7 equals 90. Divide both sides by tangent of 7. So x is going to be approximately, I don't have my calculator. Yeah, so then you would just divide 90 divided by tangent of 7 and get your value for x, and it's going to be in feet. Okay, sorry about that. I think the book has the answer. You should be good to go there. As a side note, some of you guys might notice that when you have this horizontal and this angle of depression, that 90 feet here, and if you were to draw a line here, it would be a right angle. This and this would be the same. So some of you are going to want to draw a right triangle kind of hanging outside out here, and that's okay. You can do that too, okay? You'd be looking for this horizontal instead. But I think this way is easiest. Every time you're given an angle of depression, plop it in for your angle of elevation, and then just use the triangle that you've already created. All right, hopefully that helps. Talk to you guys soon.